Hello, welcome to the Raygun assignment, where we've learned how to create prism, cube, cylinder, and sphere to some degree. Not officially cone and pyramid. I'm going to take a look at that real quick right now. That is here. With the cone, it's going to be based on a square, creating an ellipse with the points of tangency, finding the center points. From the center point, you take the central axis up. The central axis should be perpendicular to the axis of the ellipse. In other words, not oblique like this one. Same thing with the center point of the pyramid. You go from the central axis up on that. And yes, it's a vertical relationship to this. Okay, so the first phase of the assignment is going to be doing the thumbnails, and you want to do them basically orthographically, meaning flat, straight on, so that these shapes aren't expressed in terms of perspective and dimension, but just what they would look like flat from the side. This is illustrating an orthographic sensibility. If you, at your eye level, this is looking at things in perspective. You're seeing below the horizon, you're seeing the top of them. Above the horizon, you're seeing the bottom. This lamp is in perspective. You're seeing the bottom of the lamp because it's above the horizon. The bottom, the top part of this lamp because it's below the horizon. This is orthographic. Okay, it's like you're looking straight on the entire way. You're simply seeing the flat shape. And that's actually an artificial way to see, because we're always seeing in perspective, but this is kind of a more simplistic yet abstract concept. So that's what these are. These shapes are just flat representations. Now, here's some idea of these are the shapes here, and there are orthographic representations. So straight on from the side is the square face. If you're seeing it just two sides straight on, two sides, or if you're looking at the point straight on, you have like a hexagon with this in the middle. Okay, rectangular prism, side, 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 straight on, two sides straight on, the other two sides straight on. You probably won't use this kind of orientation there. The cone straight on doesn't have an ellipse. It's like a triangle. You're seeing it flat on. Okay. This is with the point, looking from the point straight on, from the bottom straight on, or if it's turned to the side, this would be the ellipse side, and that's that. But again, it's a triangle. Cylinder, the same. It's not going to read as an ellipse. It's going to be a flat line. Standing up, flat line. This is straight on. If it's on its side, flat line, flat line. This is going to be the ellipses, but they're straight on, so you don't see the ellipse. The pyramid, if you're looking straight on at it, it would be this way. You'd see just one side. Or if you're looking right down this corner, you would see two sides. Or the bottom, just a square bottom. Or the pyramid, you can also base it on a rectangle if you would like. It doesn't have to all be based on a square. What has to be based on a square is the cone, the cylinder, and the cube when you construct them. Okay, so I want to talk about the station point technique for creating a cube, which is going to help you with your proportions when you're doing your two-point perspective, which is the third phase of the Raygun assignment. So again, the station point is a 90-degree relationship to the vanishing points. And it would be a good idea for you to actually take your vanishing points off the page, I think, in general, for this assignment. And what I do for that is tape a piece of paper here and a piece of paper there that I can fold out, and then I can put my vanishing points way out on the sides and then fold them back under. And when I want to work on the assignment again, boom, there it is. So it becomes like 3 times as long, but you can plot vanishing points out there and they stay, and it's good. This is a handy way of doing it, butting up rulers like this. And you want to have the line of sight or the line of origin, which is where the station point is. That is where the viewer is looking from. This is the eye level of the viewer. This is where you're looking, the viewer is looking from. and this should be near the object or through the corner object. It's got to be close. If the object goes over here and I use the same station point, you start getting a shape like this, and it's not creating any. It's not a cube, obviously. Station point near through the object, your square unit vertically. Then you translate that square unit B and B. The ruler helps doing that. With the transparent ruler, you can get a perfect perpendicular, lining up the lines through there, knowing what the measurements are, measure. Then from here you take your convergence lines, boom, to this side, and then through this side, and then you from your station point you measure this segment, which is 1, and you take 1 and translate it up here, measure it from here to here up to the horizon line, you get measuring point 1. Same thing here, this number 2 segment, up here you get measure point 2. Now you're ready for finding where the verticals start, and it's just as easy as connecting the end of square unit B to measuring point 1, and where it intersects right there at this convergence line is where the vertical goes up. Same thing here, where it intersects right at that line where the convergence line is, that's where that vertical is. You just do the vertical, then you can connect this convergence line, and then the transparent lines that go underneath. Then you have a fairly perfect cube in perspective. If you use this as a unit of measurement, when you construct your 2-point perspective grid for your big 2-point perspective Raygun, this will give you a square template to base things off of, and a ratio that works in perspective. And I'll go more into that later. Okay, that's it for. Oh wait, one more thing. Why the station point? The station point is 90-degree angle to the vanishing points because it's based on the 90-degree angle of the cube. If we're looking straight down at a cube, it looks like that. It's a 90-degree angle, right? So thus, if you take this 90-degree angle on perspective and you do it, it looks strange because our mind thinks, oh, this angle says I'm looking straight down at a 90-degree angle. And it starts to look like a 3-point perspective, like forced perspective. This, if the angle is even more acute, then it's what I call dagger cubes. It gets even weirder, and that's forced perspective. So with things based on the square, you want to be less acute when looking in perspective. I mean greater than 90 degrees, because then that is what occurs. The angle gets greater and greater and greater as it goes to the horizon line. Okay.